Hello everyone. So today we shall discuss an interesting topic on the basic concepts of optical isomerism. So before we discuss into the basic concepts of optical isomers and the optical isomerism, we shall move on to the concept of stereoisomerism and then isomerism. First of all, let me give you a clear definition on isomerism. If two compounds, if they have the same molecular formula, but they differ in their structural formula, they are called as isomers. So those, the phenomenon is called as isomerism. Stereoisomerism, that is entirely different from the above said, the before said isomerism. That is, if two compounds, if they have the same molecular formula, same structural formula, but they differ in the spatial arrangement of atoms or groups. For example, this is the plain polarized light. That is, first of all, we must understand, we should understand the phenomenon of polarization of light to explain the concept of optical isomerism. Non-polarized light means, so we all very well know that ordinary light consisting of the waves vibrating in all directions. Whereas the plain polarized light, it is found to consist of the wave vibrating in only one plane. So when the ordinary light, that is monochromatic light, when it is passing through a nickel prism, the emergent light is found to consist of the wave vibrating in only one plane. So this phenomenon is called as polarization of light. That is, the next one is, normally we use this instrument for measuring the optical rotation values of some molecules in solution. See, what is it optical activity? What is the phenomenon of optical isomerism? All these can be explained very clearly just by looking at this picture. See, this is an ordinary light source. This ordinary light source, it is a monochromatic light. This monochromatic light, it is consisting of the waves vibrating in all directions, just like this. So when it is passing through this polarimeter tube, it is containing an optically active substance. So this optically active substance, it has the tendency of rotating the plane polarized light. It may rotate the plane polarized light either in right side directions or it may rotate in the left side directions. So if the rotation is towards the right side, we call it as a dextrorotatory compound, and if it is rotating in the clockwise direction, if it is rotating in the clockwise direction, we call it as a dextrorotatory compound, and if it is in the anti-clockwise directions, we call it as a levorotatory compound. Usually, normally the dextrorotatory compound is denoted by the symbol plus, and the levorotatory compound is denoted by the symbol minus. So this is this can be optical isomerism can be explained by using this polarimeter instrument. So in all laboratory, in chemical laboratory, we use this instrument to measure the optical rotation values of any optically active substance. So next, coming to the definition of optical activity. See, when do we say that when a molecule is an optically active compound? if only if it has the tendency to rotate, tendency has the has to rotate the plane polarized light. If it doesn't rotate the plane polarized light, it is called as optically inactive compound. Next we shall see what are the conditions for a molecule to be optically active. The first condition is it must be a chiral compound. That is the compound that carbon should attach to the 4 different groups. Then it must have more than one configuration. That is, it may be one configuration must be in excess of the other one. There is enantiomers. This one enantiomer must be present in excess of the another one. Then they must have a mirror image relationship, but they should be non-superimposable mirror images. Next one is there should not be any elements of symmetry there. So these are some of the conditions for a molecule to be optically active. So coming to this concept of plane of symmetry. So this is an so before that we shall discuss this one. So this is an example for a chiral object, your left hand and right hand. So your left hand is a mirror image of right hand and right hand is a mirror image of left hand. So but are they superimposable? No, they are not superimposable mirror images. So it is a very good, excellent example for a chiral object. So these are some of the examples of the achiral objects. Now this is a plane which bisects a molecule into 2 different halves. It is called as a plane of symmetry here. So when a molecule possesses this plane of symmetry, that molecule is an optically inactive compound. So here also we find a plane of symmetry in the molecule, so it is an optically inactive compound. And this is an excellent example for an optically active compound. Here, see here, this is a lactic acid, lactic acid, D-lactic acid. Here the carbon is attached to 4 different groups. It's a carbon, COOH group, CH3 group, hydrogen, OH. Here also carbon, COOH group, H, CH3. So 4 different groups are attached to this carbon. So it is having a chiral center here. It is these are the enantiomers. They both have the mirror images of both have the mirror image relationship, but though they have the mirror image relationship, they are not superimposable. So this is another condition for a molecule to be optically active here. So when plane polarized light, when it is passing through the lactic acid, when lactic acid is exposed to plane polarized light, this molecule, since it is an optically active compound, it has a tendency to rotate the plane polarized light either towards left side or towards right side. So if the molecule rotates if the plane polarized light rotates towards the left side, it is called as levorotatory compound, and if it is rotating in the right side, it is called as dextrorotatory compound. So hope you have very well understood the definition of optical isomerism, optical isomers, and then examples of optical isomers, and then chiral objects, achiral objects, and then the phenomenon of optical isomerism also. So these are the references we have. So you go through all these books so that you expose yourself to these references so that you gain knowledge by referring these stereochemistry books. So thank you so much for listening to my lecture on optical isomerism. Thank you.